Hello doctor, my name is Nura Aina Shafina binti Muhammad Zamri and my matrix number CE2100308. So I will begin with the introduction part. Electric energy in the context of magnetostatic refers to the energy associated with the magnetic field in the system of stationary electric charges. The energy stored in this magnetic field is a result of interaction between electric current and the magnetic field. By converting energy from a magnetic field to electricity involves harnessing the electromagnetic induction principle. So the process is fundamental to device where utilize Faraday's law of electromagnetic induction, stating that a changing magnetic field induces an electromotive force, which is EMF, in a nearby conductor. So in our project, we decided to create Faraday fan by implying the first rule of Faraday's law. So this project explains how a magnet together with coil produce current that can rotate the fan, which is attached to DC motor. At the same time, the current value is being measured using multimeter as the number of turns of coil is increased. So then the fan operates on the basis of Faraday's law, which states that a change magnetic field creates an electromotive force, which is EMF, which then causes current to flow through the coil. That's all for me. Thank you.
Okay, my name is Sharvina and now I'll be explaining about our problem statement. A normal fan run on electrical energy which is generated from renewable or non-renewable energy. So example of renewable energies are hydroelectric power using the potential energy of rivers, dams in order to create electricity. So apart from hydroelectric power, we can even use solar power where the sun is used to generate electricity in our home through the solar photovoltaic panels that are installed in the roof of our buildings, homes or office. And as for renewable and non-renewable energy, coal, oil and natural gas are burned in the power plant and the steam is used to turn the turbine in the generator in order to generate electricity. But then these energies may have any disruptions or electricity shutdown, or sometimes the equipment that they use to generate this electricity from the non-renewable or renewable energy, like for example the turbine that is used for non-renewable energy, may have any maintenance or any failure in the device. So sometimes there will be any disruption in the current. In order to have a long-lasting current, a renewable and sustainable energy must be implemented. So in our project, we have implemented Faraday's law, which is electromagnetic induction, where the changing of magnetic field linked with the conductor induces an EMF, electromotive force, in the conductor.
My name is Siti Asya binti Ismail and my matric number is DE2100102. Next, we're going to take a look at our project's objective. So the purpose of our project is to first verify the Faraday's law of electromagnetic induction, where we test and confirm the Faraday's law by understanding the proportional relationship between the rate of change of magnetic flux and the induced electromotive force in the fan application. Second, the purpose of this project is to investigate the relationship between magnetic flux and current. We analyze how changes in the number of turns in a coil affect the magnetic flux linked with the coil and its impact to the current generation and subsequently the fan performance. Third, the purpose of this project is to explore magnetic field strength and coil turns. Throughout this project, we investigate how the strength of the magnetic field influence the induced current for different number of turns in the coil based on the fan speed.
Assalamualaikum warahmatullahi wabarakatuh. My name is Azizul bin Muhammad Jamadi and my matrix number is DE2100051. So for my part, I will present about block diagram. Okay, so we have the four type of box for the DC supply, the input, and then we have coil, magnets, and also DC motor for the output. Okay, let me explain first. So DC supply is the battery. We have two type of battery. That is 3 slot 1.5 volt battery, and also 2 slot 1.5 volt battery. And then we have the coil. The coil is also variable, or we call it as the number of turns, that is n. We have 10 turns, 20 and also 30. Okay, and then we have magnets. We have two ring magnets that with 60 millimeter diameter, and we have the output that is DC motor with RPM 17k and 3 to 6 volt volt supply. Okay, that is the block diagram. Because our project is not successful, I decide to put the DC supply or battery in the circuit just to make sure we have the enough supply to rotate the DC motor.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Syahira binti Muhammad Saleh with metric number DE21050. So I will continue for the flow chart. Alright. We have flow chart here. Okay, so the process will begin here. We start with the DC supply, which is battery, and then we will connect to the magnet. Okay. When the battery and magnet is connected, it will produce the magnetic field. When magnetic field is produced, it will induce current. But if there is no current induced, it will going back to the magnetic field until it will produce. Okay, we are going back to the current induced. Okay, if yes, it will continue the process. So the current will flow in the coil and the DC motor will function. If the DC motor is not function, it will going back to the first process, which is magnetic field produced and then current induced until the current flow in the coil and the DC motor function. Then if the DC motor function, the fan will spin. So it will end here if the fan is spinning. So that's all for the flow chart.
Yep. Siapa? Apa tu? Jobman. Okay, for the second part, we have the prototype analysis and discussion. Okay, because we already fixed and put the DC supply on our circuit just to make sure it has enough supply to rotate the fan. I take three type of result from the prototype. That is first voltage, then current and also resistance. Okay, then we have six type of coil with different number of turn and also different slot battery. We have 10 turns with 3 and 2 slot battery, and also 20 turns with 3 and 2 slot battery, and also 30 turns with 3 and 2 slot battery. Okay, based on the prototype that already been made, I managed to got the voltage like this. It has different type of voltage because it had been disturbed by the value of DC supply, also the value of number of turn, and also resistance in the wire. Then we have different type of current and also different type of resistance. Okay, we can take a look at the coil number 20 turns with 3 slot battery. We got negative 0.02 current and also negative resistance. Okay, based on my opinion, because I make the I try to fix the circuit just to make sure I got the correct result. It still give the negative reading. Maybe I think because it has disturbance from the magnet, or maybe the number of turn of the coil, and also maybe because the input from DC supply is not stable. Because for the voltage, I put the probe in parallel to the circuit. For the current and resistance, I put in the series. I tested it many times to make sure that I'm not making wrong. So this is the result that I already got. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Del Hafiz bin Sulaiman, BE20304. Okay, I will continue for the last thing, which is called the conclusion. So the conclusion that our group are getting is magnetic flux change with time, causing an EMF. Increase coil turns that connect with battery, increase inductance and magnetic field strength, affecting current flow and also the speed of the fan. We also get to know that tightly wound coils produce stronger magnetic field, while stronger magnet coils produce larger magnetic force. DC power supply that we use to turn the fan also will spin faster with the increase of coil turns. Okay, that's all from our group. Thank you.